Hi guys, Mr. Gardner here, and today we're going to talk about finding the area of composite shapes. So it's really similar, it really ties into our finding the surface area of three-dimensional shapes, in that you're just finding the area of two-dimensional objects and you're putting those areas together. So the first thing we want to talk about today is we want to think about our formulas for area. So if we have, let's do rectangles for some area of rectangle. If you remember, a rectangle is either going to be two pairs of sides that are equal or a square, so all sides are equal. So a square is also just like a rectangle. Okay, and the formula for that is going to be equal to length times width. And so you can think about this as the length and this is the width. And on a square, length and width, even though all of those are the same. Okay, and that's how you're going to find the area of these things. And again, what you're looking at, you can see it in these squares, is you're finding these, how many of these little squares fit into the shape. And by multiplying how many of these by these is going to tell you how many total are in there. So that's why we use that formula to solve for the area of a rectangle. The next thing we want to talk about is area of a triangle. Okay, we have different types of triangles. All right. But we use the same formula in all of them. So the area of a triangle is equal to 1/2 the base times the height. Okay, or you could also call this the same thing as base times height divided by 2. So dividing by 2 and multiplying by 1/2, they're the same thing. You do the same thing when you do those things. And so we'll just label them here. On this shape, h is the distance from the middle of the base to the very top, and that's the base. In a right triangle, this angle here is going to be your height and this is going to be your base. You always want to measure the base from the bottom, the height, I mean, from the bottom to the very tip top in a straight line. You never want to measure height diagonally. It doesn't make sense. If you were standing right here, I wouldn't take a tape measure and run it diagonally to the floor and say something like, oh, you're 13 feet tall. That just isn't going to make any sense. I would take it straight from the top of your forehead all the way down to the ground. So that's the same thing when we're talking about a triangle. We have to measure that height vertically. We can't diagonally measure height. Okay, so just make sure whenever you're measuring a triangle's height, you're always using that vertical height. All right. So those are two formulas that we have so far. And then the next one that we've learned is area of a circle. Okay, and the area of a circle is pi times the radius squared. Okay, and if we want to just look at a circle really quick, you can see that. And radius is that distance halfway. That's your radius, right? So if you have a diameter, then you know that the radius is half of the diameter. So radius equals diameter divided by 2. So in case you're given the diameter and you need to find radius, that formula there is going to help us. These formulas you really just have to memorize to be successful here. So you just got to really commit them to memory and make sure you know all these formulas. You can always look back at them as reference guides, right? But at the end of the day, you don't want to have to constantly be Googling the formula for area of a rectangle when you can just memorize its length times width. So that's really an important part of this. All right, so now once we know our area formulas, we can go ahead and start looking at how to find area of shapes like these ones. These are all really irregular, different looking shapes. And again, if we just break them down into the shapes we know, then we can find the area of them. And we just have to use some of the information that's given to us. So let's look at something like this shape here. And I'm just going to zoom in really quick to it so you can see it better. And as we can see here, that this shape is made up of two shapes. It's a rectangle and a triangle. So we can start labeling this because we need to get some piece of information. So we know if that's 4, then this bottom piece is 4. And we can use that information to help us because it's telling us that this entire length is 12 centimeters. And we know that this section is 4 centimeters. So then we know that this piece right here has to be whatever 12 centimeters is without this 4 centimeters. And so that's going to be 8. And then we know that across from here is 6. So that means the height of this triangle is 6. Well, now we have enough information. Area of a rectangle, length times width, so 6 times 4. equals 24. And the area of the triangle, so we'll call this R, the rectangle, this T, the triangle. And it's base times height, so there's the base, 8 times 6 divided by 2. And we get 48 divided by 2. And then we get that that shape's also 24. Now, again, this one and this one are together, so we're just going to add those up. We get 24 plus 24. And we do the math there. We get 8 and 4, 48. And we always want to label these are centimeters. So 48 centimeters squared, because area is always in square units. So let's look at this next shape. This next one's a little bit different, right? Now, you can think about this as 4 triangles, or if you want to get creative and just split it here, you can think of this as 1, 2 triangles. I'm going to think of it as 2 triangles. So what I mean is if I took this line here, and here, and here, that's 1 triangle, right? And the other one's the same as this one. And the nice thing is I'm being told these distances. So this is 5 and this is 15. So that means the base of this triangle is 20. And this is telling me that this is 5. So now I know the base and I know the height of this triangle, because you would think if you just turned that and set it down, it would look like this triangle here. Right? And so I'm using that as the base, and this is the height that it's giving me. Okay? And instead of trying to find this area, this area, this area, and this area, I can just find this one and double it because these are the same. So now I know area of my triangle is going to equal base 20 times the height, which is 5. And I'm going to divide it by 2. 20 times 5 is 100. I'm going to divide that by 2, and it's going to give me 50 as the area. Now I got to remember there's 2 of them. So 50, I'm going to times that by 2 and get 100. That gives me 100 inches squared. So this next one, we're going to do the same thing here. So we're going to see that we're given a shape. It's 4 by 5 for this rectangle. And we can see that this triangle, if this side's 4, then this base has to be 4. So now we have a base and a height. Now we can find the area. Area of a rectangle is going to be 4 times 5, right? Length times width. That's going to be 20. Then we're going to do area of that triangle. And we have a base of 4. We have a height of 2. We're going to divide that by 2. That gives us 8 divided by 2. That gives us 4. Again, they're both together. When we're putting them together, that means add. We get 24 centimeters squared. So remember, we always want to square the measurement up because area is in square units. Remember, we were talking about these little squares that fit into a shape. So that's really important to do. But what happens if we have circles in the composite shapes? So we did look at that circle formula, so we do have to address what happens, because this does come up sometimes. You have rooms that might look like this, floor plans that look like this, shapes that look like this. There's all different ways. This is a heart, obviously. You can think of, just for kind of what we've been doing in class today, you can think of this as like the top of a Valentine's Day candy box, right? And maybe you want to design the logo on it, but you need to know how much space this is going to take up so that you could estimate cost of doing something like this. If you were like on a marketing team, or you were on a new design team to create a product. Okay, so this kind of stuff's important that you know these things. So we can think about something like this. We know we have a square because we have these dimensions are the same, and we're really going to do the same thing. We're just going to use the formulas we know, and we're going to put them together. Now, in this one, it's really nice. You can think about this in a couple ways. I'm going to explain it in a simple way, and then I'm going to talk about more of like an abstract thinking, kind of a higher level thinking way of doing this problem. But from here, what we see is, and we just got to make heads and tails of this. We got to make sense of what's going on. And we can see that we have this square here. So I'm just going to label this as my first shape that I have. So this is shape 1. And then I've got shape 2 and shape 3. And I have to understand that shape 2 and 3 are half circles, right? So if I'm going to use the formula for area, I'm going to take half of it because I don't have a full circle here. I only have half of a circle. But I can still make that work, okay? So the first thing I want to do is I want to find the area of that square. And I know it's 2 by 2, length times width, so I'm going to do 2 times 2. And I'm going to get the area of that square is going to be 4 inches squared. Okay, now I got to address these circles. So now again, it's telling me that this whole length here is 2. And so if I know that this length here is 2, then I know to the center of it, right, halfway is only going to be 1, right? If I'm splitting 2 up, 2 parts together has to be 1. 1 plus 1 equals 2. So then I can use my formula here that I know for a circle, but remember I got to take half of it because I'm only doing half of a circle. Okay, so this is going to be area of circle 2, and that is going to equal, what do we have? Pi r squared. Okay, and so we know that the radius is 1. 1 squared is just 1. So then we know that this semicircle is going to have an area of 3.14. All right, and so again, if we wanted to show the work, that's 1 times pi, and 1 times 1 is 1 times pi, and we always know that pi we're using is 3.14. So then that tells us that this is 3.14 is the area. But again, remember, we have to take half. So we're dividing that by 2. Okay, so we have 3.14, and we're dividing it by 2. So 2 goes into 3 one time. We get a 1. Bring that down. We get 11. 2 goes into 11 5 times. Remember, we got to bring our decimal up. That's going to be 10. We're going to get a 1. Bring down the 4. And 2 goes into 14 7 times. So then we get 1.57. So remember, we had to take half of that because it's half. All right, so 1.57. Now we can look at this. Oh, the radius of this one's also 1 when I look at it. Wait a minute, these are the same. So this one's going to be 1.57 as well. Okay, so that's one way of doing it. And then we add those all together and we get, so area of circle 3, shape 3 is 1.57. So we need to add all these together. So we have 4 plus 1.57 plus 1.57. So we just need to make that 4.00. 7, 7, and 0 makes 14. Carry a 1. 1 plus 5 is 6. Plus 5 again is 11. Carry the 1. And 1, 2, 3 plus 4 is 7. So 7. Bring down my decimal. I get 7.14 inches squared for this shape with the semicircle. Again, what we could think about too is if this half circle and this half circle are the same, if I have 2 half circles, then I just have what? I just have a circle, right? And so again, I could have just put those together and seen that that was just 3.14, which is basically what happened here. So that's kind of that higher level thinking. If you didn't see that though, then you just would find the area of each circle and you would put those together when you're adding all the totals. So area, 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 add them all together and you get 7.14 inches. So again, when you're looking at composite shapes, it's really just breaking them down into what shapes they are and then using the formulas for those regular polygons that we already know, because we don't really have a formula for a heart. Okay, I've never seen that formula. So we just got to be able to use what we know, break down the shapes, and then find our solutions from there.